right in. As many of you know, and some of you don't, my name is Greg Mulholland. I'm one of the founders and the CEO of Citrine Informatics. I'm here with Matthias Hermann, our senior solutions engineer and a former BASFer. He was a lab team leader, and so has lived the journey that so many of you are living in making sure that we are being as efficient as possible in our chemicals development, our materials development, while also trying to inject that innovation that we are all trying to bring to make sure that we're bringing our best game into our market. Um, Matthias works very closely with our customers. So some of you on the call probably know him. And those who don't, well, you're in for a treat today because he's a real value and understands really what is necessary to use AI in the materials and chemicals development process. Um, but today we're going to talk about something really, really important. We're going to talk about how to smooth the path to AI adoption. I think we've seen a lot of promising things in AI, but we have some exciting things to share that are going to help you see a larger impact across your entire organization. So with that, I'm going to jump into it. So as I mentioned, I'm one of the founders of Citrine, and early on in our company's history, probably for the first 3, 4, maybe even 5 years, we were answering the question you see on the screen. Can we get value from using AI in the materials and chemicals product development process? And the reality was, from the beginning, we kind of did. We really saw a very high level of value derived from using AI. At the same time, we kind of needed to prove it, as I'm sure all of you know and have experienced. The technical folks in our industry can be pretty skeptical of technologies that promise or at least seem to show a big leap forward in what we're able to do. And so we created an AI platform at that time that could use small data sets, the ones typically found at most of your companies and across the industry, um, to learn as much as possible about your chemistries and materials and accelerate product development. Predict which recipes might be the ones that could help you hit your customers' targets faster. And sure enough, our customers have proven time and time again that you can use these small data sets to reduce the number of experiments you need to get to your targets. And that translates into time, it translates to time and market, and it also translates to cost savings just in the lab, right? You're not running as many experiments per product. But that was the first 5 years. And frankly, we kind of nailed it. AI is now widely regarded as a very important tool in chemistry. The specific details, I think, are a matter of hot debate and one that you can often find, whether it's academics or within various companies. People have a lot of opinions about how AI can best be used. But I don't hear a lot of people these days saying that AI does not create value in our market. So what is the challenge? Well, it's actually step two. It's moving from successful pilot projects and successful early wins and successful new product launches in small numbers to daily use across global teams. And that's natural, right? There is no transformation of using technology or using a new capability or tweaking your workflow even that comes easy to everyone. And frankly, this is a pretty big change in how we think about work. And so change is not often fun. It takes work. It takes real intention. It takes leadership, and it takes buy-in from those around an organization to make sure that they're actually able to gain the real benefit of the new technology. And so we've been on a journey at Citrine for years now to help companies change as fast as possible, to adopt these new technologies and really kind of make sure they become part of the cultural fabric of a company, because that's really what you need. Um, and so that's meant both helping, sort of helping with professional services or coaching folks to scale, but it's also meant making some product changes to make the product easier to use, and also smart. We want the AI to get better day by day, week by week. And so today, I'm really excited to show you a couple things. When I say Matthias is going to show you most of it because he's the on the ground expert. But I'm really excited to show you a couple things that do just that. They allow us to be smarter and easier to use all at once. So we call them Catalyst and Apex. Catalyst dramatically reduces the effort it takes to get answers from the platform. There are a million knobs within Citrine. There are so many things you can control from all the way down at the API level to something that is much, much, much higher level, but still a lot of controls to allow you to nudge the AI in the direction that you need it to operate. Today, we're announcing something that's going to make it much easier to have a very natural conversation with the platform. The second, which we'll talk about a little bit after Catalyst, ensures that we will always deliver the best answers possible. It's a totally new modeling architecture that includes some of the most advanced models ever created for chemistry and ones that are, frankly, inspired by a lot of the breakthrough work done in other domains that we have been able to bring over into our domain. But let's be honest, I could go through 400 slides right now. I have dozens and dozens and dozens, and I'm sure you all are excited to see them. But the reality is, what I want to show you is the actual thing in use. And so I'm just going to hand over to Matthias and let him show you Catalyst so we can see how the world is changing right in front of us. So, Matthias, over to you.
Thanks, Greg. So let me show you what's actually meant by Catalyst and how that looks like. So let's assume I'm a material scientist and I need to develop a new polyurethane foam for seat cushions. I have some requirements for that foam. I need to fulfill some restrictions, such as to only use bio-based polyols, some mechanical properties, and so on. And I'm a new Citrine user. I have access to the Citrine platform. This is what I'm seeing now. And now I need to get started. My colleagues might have used it already. It is possible to generate some experimental suggestions based on the data, look for correlations. But I want to show you now how easy it is for such a new user to get started in order to get value from existing data and get some suggestions for the next best experiment to perform to, for example, get a suggestion for a new polyurethane foam formulation with some restrictions and some certain target goals. And so what I'm going to do is I'm going to use Catalyst, which is the assistant, which I can easily open here on the left side. And before I get started with creating some new experiments, I am interested to know what has been done already. Is there any materials that were tested already that could be used for me to learn from in order to get some new experiments? And so I can ask directly through the data analysis agent here, what polyurethane materials were tested. As I said, I want to create a new polyurethane material. I have some specific restrictions there, but let's look first, is there my data? Is there some data from my colleagues that I could utilize? And as you can see, the agent is starting right away, looking through all the data that my colleagues have uploaded there, and it finds 4 different related sets of experiments that can be utilized. There seems to be one that was generated quite recently in June 2026. It gives me a summary, and then I can decide based on the information that it is providing to me, is that a good data set to use as a basis to generate some new suggestions for experiments to perform, so I get my new formulation for a bio-based seat cushion polymer. And I can see there is a bunch of those, and I would say, okay, the one that was most recently used looks good. So I want to make sure that I have the most up-to-date data. So give me some more details about the most recent set of experiments here. It's going to look through that, provide some more details, and then I can decide if this one is a good one to get started, to build a model based on that one, and then get some suggestions from the platform. All that is on top of the common workflow. So for users who are already using Citrine and are familiar with the workflow, this is something that you can still do in a manual way. But as you can see with the agent, we can do all that just via prompts, just with the agent. and make it much easier. Instead of having done all manually, you can do it all in an automated fashion. It's analyzing the data, looking what kind of properties were measured within that data set, within those experiments. And it seems like there is a bunch of properties that seem suitable. I know for sure that the LOI, in order to get a good flame retardance, is also something that I have to optimize. So it's good to see that this has also been measured within that set of experiments. And it looks good. However, something else that I'm curious about is how does the price of those bio-based polyols, which is a key ingredient in that whole process, compare to the other ones? Is that something that I should consider? Is it more expensive? Usually bio-based materials have a premium associated with it. So it's going to look through that and checks if there is a difference in the price. And then, depending on that, it might be something that I have to consider when I'm generating some new formulations, making sure that I'm also minimizing the price and not only looking for optimizing some specific mechanical properties or flame retardant properties. So looking for it, checking if there is any bio-based ones, and it seems like there is some bio-based polyols that were tested within the data set. It finds also some cost information for those. And it seems like there is 3 of these which have a slightly higher price than the conventional polyols, which were also tested. It gives me a summary, tells me that the bio-based polyols, as expected, have a slight premium, which I should consider. But this is something that I can then keep in mind when generating some new experiments. Now, besides the price and besides the flame retardancy, I know also mechanical properties are key. And I know the Zugfestigkeit, this is something that I want to optimize. Don't remember what the English name for that particular property is. So let's give it a try and answer or send a question in German to Catalyst and see if it understands that. I know the Zugfestigkeit also is something that needs to be optimized, and I would like to know what experiment has the highest Zugfestigkeit. So it's looking through the data set, that set of experiments, and it finds, yeah, experiment number 3 seems to have the highest one. So I can click on the link here, open up directly that experiment, get some more details, and I see, it's the tensile strength. This is the word that I was looking for. But as you can see here, you can also communicate with Catalyst in different languages, and it will also understand, tensile strength is the direct translation of the Zugfestigkeit here, and is capable of understanding that and also able to respond in different languages. So looking at the data now, it seems this is a good set of experiments that I can use as a basis to create some new experiments to optimize for different properties. So after analyzing the data, I can switch the agent and can go to the guided project and candidates generator. And now I'm specifying that I would like to utilize that data set that I just looked at. And I'm specifying I would like the LOI, which is a measure for the flame retardancy, to be above 26. This is a requirement from my customer. And as I said earlier, I also want to make sure that only bio-based polyols are used as ingredients. It's now checking if the data contains the relevant information, if it is possible to create a new set of experiments based on my requirements that I'm setting here. It's finding, again, a few different data sets, but yeah, as I said earlier, the one that is most up to date is the one that I would like to use. So I'm saying, yeah, use the most up to date data set, reviewing that one again, making sure that it all fits. And then it will check what other properties might there be in the data set that it could also optimize for. Maybe there is some other properties, some other mechanical properties that would be suitable to be optimized in order to get a new material for a seat cushion. And so based on my prompt, it specifies the LOI for the flame retardancy needs to be maximized as my target here. The tensile strength, since I asked about it earlier, the Zugfestigkeit is also something that it analyzes and it finds a different range. And it also understands that I have the specific constraint of only using bio-based polyols. So let me be a little bit more detailed here and say the LOI needs to be above 26. I also want to minimize the cost. As we have seen earlier, the polyols that are bio-based tend to be more expensive. So let's see if we can keep the price of the final formulation low by giving the instruction to Citrine to also minimize the cost while also maximizing the flame retardancy, but also making sure that we have a high tensile strength. So it understands now what my targets are, minimizing cost, maximizing LOI above 26, and maximizing the tensile strength above 10 megapascals. Looks all good to me. So I'm going to say, sounds good. And it goes ahead and starts generating the workflow here. And you should see now in a moment that we have here a bunch of projects, and it will now automatically, based on those prompts, generate a new project here, which, doesn't need any more input from my side. Here you can see PU seed cushion, bio-based polyols created by me today is now generated. This will take a few minutes. And while this is happening, I'm now also curious to see if some of my colleagues potentially have already generated some other candidates that are also using similar ingredients. Because in my work as a solutions engineer, I have often seen in discussions with prospects when I ask the question, can you be sure that the experiments that you performed are performed for the first time? Or is it possible that some of your colleagues have done that in the past, or that some of your colleagues are doing similar experiments in parallel? And a lot of the customers or the prospects are not absolutely sure about that. And it's unbelievable how much resources can be wasted by doing experiments repeatedly. So let's use Catalyst again to review or check if there is some other candidates that have been already generated using similar ingredients. So I can now go to the other assistant here, which is the candidate analysis assistant, and ask, are there other projects and candidates that use ingredients from that data set that I just used in order to create some new candidates? Making sure or checking, maybe there are some colleagues who are working on something similar. Maybe there is colleagues who are using the same ingredients. So I could potentially ask them to give them to me so I don't have to order them. And we will see what it comes up with. And it seems like there is another project predicting glass transition temperature of polyurethanes. So it's a different application apparently, but it also focuses on optimizing polyurethanes. And then there is also the project that we just created, Seed Cushion Bio-Based Optimization. As I said, it's been generated, it's been training right now in the meantime. But I'd be curious to see what kind of experiments were done here and who is doing those experiments. And so it might be worth reaching out to that person and get an idea what was done there. We can see for that other project, there have been already some experiments suggested by Citrine, which are listed here. And what I can do now is I can review those in more detail, see what kind of ingredients are utilized here and what kind of objectives and goals that other person tried to achieve. So let's open up that project and we can see this is one of the candidates. I can see it is pinned. So apparently my colleague here also wants to start measuring that. And if I go down, I can see Bob is planning to test it next week. So might be worth reaching out to him and checking what exactly he's working on, what kind of ingredients he has, what he's trying to do, and making sure that we are not doing any redundant work. So in the meantime, the platform is generating that other workflow that I just created for myself. But I would say let's learn a little bit more about Apex in the meantime, and then we can review those candidates that the platform is creating now. So back to you, Greg.
Well, thanks, Matthias. Yeah, excited to share a little more about Apex while we let the system churn. So, we just saw a Catalyst, and that's a really, really exciting capability that'll make things much, much easier. And you'll see in a minute what exactly it's done once it's finished running. Now, I want to talk a little about Apex. Catalyst was all about reducing the barrier to using the Citrine platform, but still putting the control in the hands of a product expert. And that's really, really important. But Apex is now the way that we make the Citrine platform even smarter. And it's a total paradigm shift for us. We have figured out how to use frontier models, the same models that underpin AIs across many different domains, but are generally trained across the entire internet or trained across huge, huge data sets. We've learned how to make them work on small chemistry data sets. No one else has been able to do this. It required a lot of breakthroughs and hard work by a tremendous number of people on the Citrine team. And it's been an investment of years. But before I talk about what it does, let me talk a little about why we thought this was important to work on. So in 2001, so think way back, about 9% of material scientists were 60 or older. And so these are folks who are imminently approaching retirement, thinking about what comes next in their career. And I'm sure many of you have seen the experience of, that key chemist, key material scientist, key person that comes in and or is a key person on your team, and then all of a sudden they say, "Hey, it's time to retire." And so you might put a fresh PhD with them for a couple of years as they're sort of ramping off of projects. And then you hire them back as a consultant for 20 hours a week at some obscene price if they're willing after they retire. And that's a huge challenge. And so it was 9% in 2001. By 2022, that number was 17.9%, almost 18%. It had more than doubled during that time. And so, what do we do? This is not a huge, I mean, this is a huge issue for so many companies because we're losing key knowledge that's allowing us to innovate. And so, we have these experienced product experts that are retiring. And what we've been able to see is that we are able to use the Apex models to perform as well or better than the best in class models after expert tuning 95% of the time. So, what this means is an Apex model off the shelf before you integrate that person's knowledge, which is something that, as many of you know, is really Citrine's specialty, bringing that knowledge to bear. We're already seeing models that are as good as the models that we have been using until today, with all that extra tuning. Apex naive is equal to our current models in a tuned state. And so, what does this mean for your team? It means that while adding domain knowledge to the platform really adds value, your less experienced team members can start from a really strong place from minute number one. And that's really, really key because it means that you're actually able to scale in a way that's super, super powerful. The other thing is that we need to accelerate our discovery cycles. We need to improve how we're actually responding to a rapidly changing market. I don't know if you all live in the same world that I do, but every morning I wake up and it feels like the economy or customer demand or some global geopolitical thing has taken a massive left turn from what it was the night before. And what that means is we constantly need to be thinking about how do we make products differently? How do we make new products? And how do we optimize our business to fit the changing world as it is? And so getting there faster is important. These models get learn faster too. They actually allow us to achieve target properties twice as fast as the current best in class models. And so that's huge. Takes an already massive AI improvement and it allows us to go even further. And all of this together increases our product development productivity. It allows us to be more responsive as an industry. And it allows us to expand the footprint. The way we started this whole thing with Catalyst and Apex, it allows us to expand the footprint of who can use AI to encompass not just your product experts who are really deep in their careers, who have a lot of technical knowledge that can couple with the AI. We can also bring in the new folks, the folks that have recently joined your company or who might not know your chemistry quite as well as they will 5 or 10 years from now. So how does this work? Well, the first thing is, we're not here to tell you that we've invented this chemistry supermodel that can learn everything all at once, that can actually solve paints and metal alloys and textiles and personal care products and all these different chemistries. We're not here to tell you that those are that we have one model that will rule them all. That is actually kind of crazy, right? If you think about alloys and grain structures and processing versus paints and coatings, where you're blending liquids very often or casting films, versus things like textiles, where you're pulling fibers and thinking about how the various additives interact as you take them through an extrusion process. All of these things are extremely different. The chemistry and physics within them are extremely different. And so we started to take a pretty different approach rather than talking about using these models, trying to find one model that will understand all of chemistry, we said, well, why don't we develop a whole array of models that will allow us to expand the footprint of what we can do, test against those models, and then use the one that works best for the application at hand. And so we actually did a bunch of benchmarking and we showed uh, quantitatively and authoritatively that no single model could dominate all of these things. And so what do? We now run many, many different model configurations. And then we automatically serve the best model to you to get your answer and to take advantage of the best in AI while leaving the other stuff behind. And sometimes what I like to say is there are, sometimes you need a transformer or a graph neural net or some other really advanced foundation frontier model. And we are building in really exciting frontier models here. But sometimes linear regression works really well. And I don't know why you would use a crazy nonlinear, incredibly powerful but incredibly slow model, or maybe not incredibly slow, but slower model, when a linear regression is actually the right tool for the job. So at Citrine, we are not throwing anything away. We are bringing together all of our historical models, all of these new Apex models, and frankly, we have new models under development today that are even beyond what we're releasing today. And so our hope is that we can constantly be adding to this portfolio so that you are always getting the best possible answers. And the exciting part about it is we can do this seamlessly. So when we decide that a model is ready for prime time, we can inject it into the platform and it will start working on your data as is today, without your needing to change a bunch of settings or think about what model you're using. It will automatically choose those models for you. So expertise will always give you a leg up. You can adapt and tune your models. And we have trained these models on very important chemical information. Apex models, they use physics and chemistry in ways that a scientist would. We pre-train it on understanding the periodic table. We pre-train it on things like learning how atoms bond, being able to expand the footprint of what molecules we're able to accept by actually making sure that we understand not just what an ethylene molecule is, but what the idea of these atoms are, how these electrons actually interact with each other, and how ethylene, frankly, interacts with the molecules around it in a complex formulation or in a complex recipe. And so one of the things, I mean, in some cases, just speaking material science is the most interesting part. It can, for example, recognize when the same property you saw earlier when Matthias was referring to tensile strength in German, and I don't speak German, so I'm not going to try. But it's a case where we have different words used for the same things, and that's really important because many of your organizations exist across international boundaries. So you might be using a capability in the US that is different in Germany, that might be different from a site in Japan or in China or in wherever else you might have locations. And so in Catalyst, it also, you might have noticed, it also recognized that PU and polyurethane are the same thing. And so we have built foundation or frontier models that are based on things like graph neural nets Transformers. Transformers are the things that underpin all of the LLMs that you see and can sometimes be quite useful in chemistry and other very interesting modeling technologies. And we've combined them in a way that no one has ever done before, which is so exciting, so powerful, and is laying groundwork for so much more to come. But you've heard me talk for plenty of time, and I'm crossing my fingers here. Uh, why don't we go back to the Citrine platform and see if Catalyst has finished setting up our project? So I'm going to unshare my screen, and Matthias, hoping that things are done. It's done crunching the numbers.
Yeah, it has. So let's have a look what Catalyst was doing in the meantime. It created an output here. This is where we stopped. I said it sounds good. We set up all the constraints and the goals that we would like to achieve. And now you can see what it was doing in the meantime. It created a project. We saw that the project was created here in parallel, build the training data, provide some more details on what data, what experiments was used, on how the predictor was built, a lot of details on that. Also, the restrictions that we were setting up regarding only using bio-based polyols and so on. And now it got some results, and it shows me here the top candidates, the top experiments that the platform created in order to test for getting those target properties as we specified them. So you can see there is a lot of them, up to 50 different candidates or even more, and it selected 15 of those. So ranking them depending on whether they are more cost effective, whether they have a higher tensile strength. And now we pick some of those. And it could be a bit overwhelming now picking the right candidates. Which ones should I pick? Which ones are the ones that I should test? How do those actually look? So let's dive a little bit deeper and get an idea what the candidates look like. So I can open the project and go into the candidate analysis and ask it, show me the experiments with the lowest cost and the highest tensile strength. Those were two of the properties that we were trying to optimize besides the LOI. And so it's now looking through those candidates it found there. And there were a few different objectives that we were trying to achieve here. It gives me, again, a little bit summary and tries to sort through the candidates a little bit, making it easier for me to pick the right ones. And we can see here, candidate 10 to 1 seems to have a good ranking here, has a tensile strength within the desired range. The cost is also below 250. Then we have a few other candidates that might have a higher tensile strength or a lower cost. And again, it lists me a few of those candidates, gives me some hints on which one to pick depending on what exactly I would like to focus on. But I can't test everything. I know we have limited resources. Experiments are expensive. Other people are also running experiments. And I know I can only run 5 experiments this week. So let's just ask Catalyst directly and tell what the situation is. I can only run 5 experiments. Which experiments or what experiments should I pick? So now, again, it's evaluating the candidates and trying to find a good mix of different experiments that I should test in order to improve the model, in order to get closer to my desired properties that have a high likelihood of achieving those goals that I was setting up. And so you can see here, top 5 recommended experiments, starts listing them here. Candidate number 1 with the predicted properties. And all those experiments that it is suggesting me here are completely new. It's using the data set or the experiments that we used in the past, built a model based on that, and gives me some suggestions for experiments to do. So I can open those, review them. I can see what the predicted properties are for that particular combination. It gives me a new formulation telling me how much to use of the different ingredients, what the process parameters are that I should utilize here. And if I want, I can refine it more. I might see the post-cure time is too long. I can go back to Catalyst and then also add the requirement, give me only suggestions that use a shorter post-curing time. I would then pick those experiments depending on what the goals are, go into the lab, test those. I have an actionable output. And with that, I have, based on my old data, some results created. And all that with only communicating through the agent. I still have control. It's still asking me question what my goals are. And it's not doing everything by itself, but you can see it is much, much easier to create an entire workflow and review candidates, collaborate with each other through that agent. All right. With that, back to you, Greg, for some final words.
Oh, well, thanks, Matthias. And our first of all, really, really cool. Thank you for doing that. And as I'm wrapping up, I would encourage you, we will have some time for questions at the end. So if you have questions about what you've seen today, please use the Q&A button at the bottom of your screen to enter questions. We've had a few come in, but I'm happy to have more, given that we have a little bit of time. So what I hope you have seen today was Apex and Catalyst are really designed to support scientists and allow them to basically gain the value of AI faster and faster. Now, I am the first to say there is no AI scientist yet. There is no scientist or no AI that can do the job of the lab expert, the lab chemist, the lab material scientist entirely, or really at all. This is a giant calculator that allows us to make much, much better decisions, but the robots are not coming for us yet. And frankly, I think we're a very, very long way away from that. But by coupling scientist knowledge and by bringing that together with AI, we can find much more subtle and important connections within our chemistry to make better decisions in our business and get to those results that we all want to see faster and faster. As always, you are able to review what is causing the system to perform. So whether that means there's some additive or some process step or something else altogether, you're able to see in the platform whether using the Catalyst agents or actually just clicking around yourself. You can review the performance drivers, the rationale for why things are working, and understand the trade-offs in your system. There are some recommendations that are meant to guide the next experiment. So it's not just a list of dozens of experiments that you could run, but it's actually a ranked list that says, hey, here, if you're trying to learn as much about your system as possible, you can do it this way. If you're trying to just get to your answer, you can do it that way. And you can actually have a more meaningful and thorough conversation with the data in the platform and with the candidates that the platform has generated much more efficiently. But as always, the scientist is in control. Your expertise is really, really valuable. And that is the thing that we leverage on every single day because with the levels of data that we have, there isn't a complete chemical model anywhere. It is by coupling your knowledge with the data that we're able to do what we do. And so I'm really excited to have had a chance to share all of this with you. Um, I think we've seen the benefits of AI in our field already by making materials less toxic, by making materials higher performance, and by making them lower cost. And frankly, lately we've been seeing a lot of folks who need to substitute materials because of supply chain snarls or other geopolitical issues. And so we're able to see that Catalyst and Apex are expanding the footprint of what we're doing already. I'm really excited to see this next step in AI for materials and chemistry, leading to faster adoption and higher productivity. And we're really proud to work with a great number of companies. We've worked on almost 400, that's even shocking to me, separate projects each month. So this isn't in Citrine's history. This is each month we're pushing 400 projects. And in many cases, we're working over 3 and 5 and 8 and 10 year relationships with some of the companies on the screen. Um, the Citrine platform has been proven at scale dozens and dozens of times, and yet we're just scratching the surface. From adhesives to plastics, coatings to CPG, from mining to automotive, we're seeing more and more companies bring AI into their workflow. And frankly, their main complaint to date has been, how do I put this in the hands of more people faster? And how do I scale this thing faster? Because one project at a time isn't going to do it. So we know AI works. Catalyst and Apex are the answer to that question to help everybody start using this thing. So with that, we're going to go to some questions. And so I'm pulling open the questions panel here. I'm also going to stop sharing my screen since you know what the word questions look like. If you want to reach out to us, info@citrine.io is available to you, or any number of the other channels. But I will start jumping into some questions in here. So, um, there was a question about whether, I believe this is probably somebody who knows the platform pretty well, whether this works with multi-step search spaces. So for those of you who aren't aware, there are two ways to use Citrine's platform: the historical way, which is sort of more formulation oriented, and then there's what we call multi-step, which allows you to bring in sort of a whole process flow diagram. And indeed, the features within Citrine are first of all, we are moving more and more to the multi-step as our default. That's what we encourage people to use today. And everything we build supports multi-step natively. And over time, we will probably move entirely to multi-step, if I'm to be honest, because it's just a more flexible way to model things. And I think people have found it to be quite easy to use and quite intuitive. So yes, everything that we do will support multi-step. Everything we do is intended to work in that direction. Um, the time Someone asked about the timeline for Apex. Are the new arrays of models already available? And are these model additions part of existing licenses, or are they add-ons? So they are rolling out as we speak. So we have them in production with a few folks, and if you are a current Citrine customer, talk to your customer team, your customer success manager, your materials informatics engineers. These folks can give you a specific timeline for your deployment, and it's a matter of just making sure that whatever specialty capabilities you have in your system, we make sure that they're fully supported. But we are able to use Apex across a great number of our customers already, the vast majority. Please please have a conversation on your regular calls with the team, and we'll make sure to get those turned on for you. But imminent is the answer. We are doing this as we speak. Um, and then, how much historical formulation data is recommended before the AI starts giving reliable predictions? And how do you prevent overfitting when only a small number of experiments are available? So, oh man, this takes me back to the original Citrine days. But actually, I'm going to hand over to Matthias because I think he's the more expert on the ground today, and then I will fill in maybe some historical notes, just
Mhm.
for interest if folks are interested. But Matthias, I'll hand over to you.
Thanks. So yeah, great question. A question that is coming up over and over again. So what we see, 20 to 30 data points is a good starting point to get a good model and good first recommendations. And the majority of our customers have less than 100 experiments to get started. And we see some good predictions with that number. If you have more, great. But yeah, 20 to 30 as a guidance is a good starting point. Preventing overfitting, there is a bunch of different ways of reviewing the models that are generated. It's not a black box. It's something that I haven't shown today. But once you generated a model, you can check what the correlations are the platform and the model is picking up on. And so you have ways of adjusting the model, making sure that no overfitting is happening there. As Greg said, the expertise of you as a formulator is still valuable and is something that you will still continue to use over the workflow, and is not something that will be obsolete here just because we are using the prompts and we can generate those models automatically. There is a lot of ways of refining that, checking what subset of data makes sense, whether we use a bigger data set or not. So a lot of details to cover here. But yeah, that's basically it. 20 to 30 data points and a lot of control on the performance and reviewing the performance of the model.
And just to add a couple additional points just from history, that might be helpful. The first is, we often see people very focused on model accuracy metrics. R squared being really high, NDME, non-dimensional model error, being very low, F1 scores being very high. That is a way to judge a model. And quite frankly, you should use those tools to get a first impression of what your model score is. But the important thing to remember is those are metrics that are relatively inherently flawed in a lot of ways, especially for new exploration. What do I mean by that? If you have an R squared of 0.98 in your system, you are probably overfit, to be honest. Chemistry is too complicated to get that level of R squared. But the other problem is you're probably not able to take that and branch out to new areas of chemistry. And that's a really, really big challenge. So what I generally recommend, and this is Greg's rule of thumb. This isn't even official Citrine policy, though it's informed by a lot of years of working in this space. Generally, I say between zero point 0.6 and 0.85 R squared is kind of your ideal target, because what that means is the model's found signal, but it's not so focused in on the things that made these materials work. It's actually learning a more general story. Um, which brings us to the question of overfitting. Um, this is one that is really tricky because Citrine does something that I'll be honest, I don't always love. We use for those of you who know data science, we use a cross validation method called leave one cluster out cross validation. It's a method that we created almost a decade ago, I think, and published. Um, the problem with materials is that a lot of materials cluster, right? You've got a bunch of things over here and a bunch of things over here and a bunch of things over here. And so if you have three clusters and you sample equally from each of those clusters, you're pretty close to overfitting because things within the same cluster often have a lot of the same capabilities and performance. But it means that if you try to predict outside of those clusters, you're going to run into trouble. You're not going to have predictive power. And so what we actually do is we identify those clusters, train across two of them, and then test on the third, and then do that in turn, or however many there are. And that is actually a really robust method. It's actually the sort of the most honest way to test the model quality, but it does mean that your R squared is lower because the thing you're predicting, you're sort of setting the bar as high as you possibly can. You're doing it the hardest possible way. And so it allows us to prevent overfitting pretty aggressively. It also means that sometimes we're a little hard on ourselves with our R squared values. So this is a constant discussion within Citrine, though. We, as I'm sure you can imagine, have a lot of very opinionated chemical engineers, statisticians, machine learning folks, AI folks. And all of them have different opinions about what is the best way to do something, what is the best way to achieve the goal. And it's an always evolving story because making sure our models are good and making sure they're capable of achieving your goal are sometimes in tension, at least superficially. We want to make sure that's really clear. Let's see what else we have for questions here. Can the model recommend new ingredient combinations that have never been tested before while keeping them chemically feasible? Um, Actually, yeah, that's our number one use case. I'm really proud of this. So our capabilities are um, basically rather than thinking about ingredients as ingredients, because we understand chemistry, we project backwards. So if you add a new ingredient, the system looks at the chemical structure, it looks at the properties of that ingredient, maybe the vapor pressure or other sort of very fundamental capability or properties of the material. And then we're able to use that to project into this new chemical space, which is the reason we do that clustering learning. It allows us to make sure that we're able to accommodate things like new ingredients without having the model just kind of wobble and fall apart, which is what a lot of normal models would do. They would see this new thing and just come up with something crazy that actually has no grounding in reality. And so this is one of our biggest use cases and something that I'm really proud of because what it's allowed us to do is remove toxic chemicals from a lot of things. So we've had lots of customers, whether they're trying to get rid of things like PFAS or BPA or just something that's super expensive. It's not always toxic. Sometimes it's just something you don't want in your supply chain for whatever reason. And we're able to bring in combinations of new chemistries that achieve this goal, but it's because of this capability. So a well-worn road for us. Um, can I have Catalyst on my in Apex my local servers deployed? We are entirely cloud-based. We unfortunately, with the level of orchestration we have and the complexity of these models, we can't deploy into somebody else's server because it would just mean that if there's ever an issue, we would not be able to fix it for you. And we've learned our lesson on that one the hard way a few times. And so we want to make sure that we're able to keep things running smoothly, and so we run everything in the cloud. Um, can I ask the agent to give me some experiments to strengthen the model as well? Yes, you can. And this is an evolving story. We have some basic capabilities there, and we have more agents coming. So the beautiful part about this agentic framework and this approach is we're able to make these sort of add agentic capabilities very quickly with time, and it's something we're continuing to think about. Um, can Catalyst help us analyze, compare, and build predictive models for a specific property? So I would just I'm just trying to go through quickly because I know we're getting a little short on time. But what Matthias showed you was exactly that, right? If you rather than just saying like the larger sort of higher level query that Matthias put in, you could say, hey, give me a PU foam with these four properties. And indeed, it will do exactly what it just did for him. End to end, it takes, I don't know, you saw it takes about 10 minutes or something. It's not a terribly long period of time. It actually configures everything and trains the underlying Citrine model. Um, the point I want to make very clearly is Catalyst is not new technology at the core level for Citrine. That's Apex. Apex is our new modeling stack. It's doing a lot of really cool stuff. Catalyst is just this autopilot that sits on top that allows you to control the system in this agentic way that's much more advanced. But it's still just using the Citrine models under the covers. And so everything you can do with the Citrine models, we can do with agents as we release those agents. I had a question about are there limitations around the formatting of data? If I had a file with quality statistics for raw materials lots, could the model connect it to a different file with final products that have the raw materials listed with lot numbers? Yes, we can. This set of functionality that we're talking about today is less about the data ingestion and processing. We'll have more to share there before too long. But this, that sort of interconnection of data is something that we do very effectively. Talk to your customer team or come and talk to our sales team about how we do that, because the devil's in the details, as I'm sure you can imagine. Sometimes we see these beautiful spreadsheets that are, amazingly interconnected. We can do a lot with them, and other times we have what I like to think of as Greg's old spreadsheet. When I was doing materials development myself, there was a spreadsheet on my desktop that probably I was the only one on earth that could read. And so depending on what your data format looks like, Matthias knows. I see the smile. It can kind of go in either direction, but we'll have more to share on that over time. Um, can I ask the agents? We did this one. Let's see. I've just got to track my questions here. Um, During model creation, when you add properties like the density and vapor pressure to the model, does Citrine know and understand what those properties mean chemically? It was my understanding that it was learning the significance with each model creation. So it depends on the property and it depends on the model that gets used. There are models within our system that just see numbers. They don't actually care about the material's properties. And sometimes that's really powerful because sometimes the chemistry information we have doesn't add up to the answer that we get. And that can be for a lot of reasons. We just haven't collected the right data. Sometimes it's that we don't know what we should be collecting. Honestly, there's lots of times, even in my own career, where I've had a limited time budget and I just measure the things that I thought were important, but might or might not actually be the really important thing. So that's the first thing. The second thing is when we have this, things like vapor pressure, um, the Apex models are using a totally different way of encoding that information. And that's one of the most exciting things. I didn't go into the technical detail behind how these models work, both because some of them are Citrine's secret sauce, and partly because I didn't want to drag everybody through a lecture on AI. But some of the embedding models we use and the ways we encode the data before it goes into the AI model are able to understand what those relationships are. And we have the best part about Apex, which we didn't talk a lot about today. We've talked about it at a previous webinar, is that it allows us to iterate very quickly, which means some of the models that we've released today are really advanced, but have a much more advanced version coming in the next months or so, that we've already been working on internally to bring in even more of that chemical knowledge. So the stuff that isn't in there today may well be there in the very reasonably short-term future as we prove them out, benchmark them, and make sure that they'll work across a large number of our applications. Um, the models recommend totally novel monomers beyond the formulation that may not have been tested in the past. Talk to your customer team about that. The devil is definitely in the details there. What I would say is Very often, yes, but the question is, how far do you want to search? It's a question of practicality. If you come up with a monomer that is synthetically difficult to reach or synthetically difficult to reach in high yield, you might not even want to try that monomer. But if it's a monomer that you can buy from a supplier and you can get it at 99.9% purity at whatever great price you can negotiate, we can definitely bring those in. So it tends to be more of a question of what is the practical limitation on these things, and less of a question of why can we actually calculate it. It turns out that AI is very often not the hard part. The messy realities of the world are very often the hard part. Um, so I think I've gotten through most of these. There are a couple really detailed questions here. We will follow up with them via email after the session. But in the spirit of trying to get everybody out on time, we will wrap up here. We will share make the recording available to the folks who are in the meeting today. Thank you very much for being here. The world of chemistry and materials and the world of AI have never come together like they are today. And that's not just Citrine. There are more companies than ever trying to create new AI models. There are more companies than ever implementing AI at scale using Citrine and really trying to make sure that they're staying at the forefront of both chemical technology and computational technology. And so we're really proud to be at the forefront of this industry. We're really proud to have really the top team that we could possibly ask for, and I'm very thankful to Matthias for taking the time today to take us through the actual thing. This is not vaporware. This is not something that is a product that maybe you'll see one day. This is coming, and many of you already have it. And if you don't have it already, like I said, talk to your customer team. It'll be out to you in a period of time measured in days. So thank you all, and really enjoy the rest of your summer and look out for more exciting things from Citrine in the coming weeks and months. Thanks, everyone.